Guys, so somebody actually sent me this question and they wanted help with finding the derivative of this, and I just thought it would be okay if I do this as an example on YouTube. It might actually help somebody else out there. So let me rewrite this if you cannot see this properly. This is y is equals to 2 multiplied by the fourth root of x squared plus 1. So now actually there's a law in derivatives. One of the rules for derivatives, not a law, it's a rule for derivatives, that says when you're trying to find, let me zoom in here, when you're trying to find the ddx of some constant multiplied by some function f of x, you're allowed to get the constant out of the way and find the derivative. So that's the ddx of that function f of x on its own. So we're going to apply this to here. We're going to apply this to this particular problem that we're looking at right now and say that since I have a leading coefficient and then there's a function, I'm going to take it out. So I'm actually trying to find this. I'm trying to find 2 ddx of x squared plus 1. Let me zoom in so that I can write a little bit bigger. The fourth root of x squared plus 1. So now the way to solve this is that we actually need the chain rule. So the chain rule says that if you want to find ddx of some function f of x, the chain rule, but you should know that the chain rule is usually applied to functions that take in as input other functions. So you're actually trying to find the derivative of f g of x. Okay, so I'm trying to save space here, so let me put this here. Let me continue writing it there. So you're trying to find, so in the chain rules, it's always the case. You're trying to find, it's only applied when you have the input is another function. So another way to write this particular function is actually f of u, where g of x is equals to u. Sorry about that. Where g of x is equals to, g of x is represented by u. So the chain rule then becomes ddx of this is equals to f prime, so that's the derivative of f multiplied by u, and so is with input u, so the u doesn't change, and then we multiply it by u prime. So this is the chain rule. So first we need to find out what is f prime. So let me go here to the far end and say f prime, f is equals to the outer function. So another way to represent this particular function, what's actually easier for you to do, is if you say, if we're just focusing on this part of the problem, then we multiply with the 2 at the end. Is another way to actually say this is to say that you open brackets x squared plus 1 and then multiply with 1 over 4 as the exponent. Right, so this 4 here is this 4 that is here. When you write this as a fraction, the number that says the one that goes at the bottom, and if we are multiplying, let me use this pointer thing here, if we're multiplying the inside part by anything, that goes on the top. But you're gonna see this as the problem goes. So we're trying to find the derivative of this, and it's easier to see that this inside part is the u and the outside part with the 1 over 4 is the f. So we can say that f, let's write first f is equals to u 1 over 4, and f prime then becomes, if we apply the power rule to f of x prime, the derivative of f, it becomes 1 over 4. We can just apply the power rule to this, 1 over 4 u minus 3 over 4. Right, so now let's look at what u is. U is this input. U is x squared. U is x squared plus 1. So then u prime, if we apply the power rule, know that the derivative of a constant is a constant, so this is going to fall away. But the derivative of this we can find. I'm saying that the derivative of a constant is 0, so this is going to fall away. But we can find the derivative of x squared, that is 2x. Right? So now we have everything in order. We can come and then we can apply that to our power rule. I want to make sure that everything here fits on the same page. So let me do this. Okay, now I'm applying not the power rule and the chain rule. So now I'm applying the chain rule and I need my f prime. So we're saying ddx of the function of this particular function is going to be equal to the, because I still have to multiply it by 2, remember. So first I'm going to find f prime and I'm going to write it. So we already have f prime here. It's 1 over 4 multiplied by u and negative 3 over 4. But I mean, why write u here when we know what u is? So you don't need to, you shouldn't write u there. You should write what u is. And u is x squared plus 1. And this is 1 over 4. Sorry, this is not 1 over 4. Sorry. This is f prime. So that's this part here. That's negative 1 over negative 3 over 4. Right? Multiplied by the derivative of u, that's 2x. But you know that this part here can actually multiply with this part, right? So let's actually rewrite it that way. Let's say this is going to be equals to, let me go back to white. This is going to be equal to 1, so now we're multiplying 2x times 1 over 4, 1 times 1 over 4, 1 over 4. My handwriting here, it's like it's impaired or something. I don't even know what that means. But anyways, then you multiply with x squared plus 1. I'm trying to do step by step here. I just don't want to skip random steps because I want you to understand. 3 over 4. Right? So this is now, so I still have an extra line here before I cross over to the other line. So this is going to multiply with this. So this is going to be 2x over 4. Now this part of the problem here, right, this is raised to a negative. Now I need you to know and understand that each time you have a negative, let's say for example, let me go here. Let's say for example you have 2 to the negative 1. This is equals to 1 over 2. If you have 2 to the negative 2, this is 2 to the negative 2. This is equals to 2 over, this is equals to 1 over 2 negative 2. The idea that I'm trying to point out here is that if you have a negative, the negative means it's a fraction, right? And the power remains the same. Only the negative makes it the fraction. So this is not over negative 2, this 2. The power remains the same. The power stays with that. But the negative has to go. The negative makes this a fraction and the power remains. So 3 negative 6 is equals to 1 over 3 6. Do you get what I'm trying to say? So with that being said, let's go back here to our problem. And we're saying that now we can rewrite this as a fraction. So you can say times x1 over x squared plus 1. And this is 3 over 4. Now, how can we rewrite this? If I have a fraction, we talked about this earlier when we changed this to be a fraction. This 4 goes on the bottom, but the 3 is the exponent for this. The 4 makes this a root, but the 3 makes the 3 stays with the number. So the root part of it is the 4th root. All right, I hope I'm making. So let's rewrite this. So we're saying that this is going to be equal to, now we can say that to this part of the problem, this is going to fall away. When this, I'm going to be left with the 2 at the bottom. So this now becomes x over 2, right? So let's write this as x over 2 is being multiplied with 1 over the 4th root. Let me write it a little bit bigger. The 4th root of x squared plus 1, all this to the 3rd power. So this is what it means. Can you see that the 4 went outside and the 3 becomes the multiplication for that? Okay. So now we can continue and say that, remember when we started with this problem, we took out this 2 here and we must bring back the 2. So this entire derivative here is actually 2 multiplied by 2. This is the 2 that we took out earlier. And when we multiply these things together, we're going to get x over. We're going to get x over 2 because of this 2 here. This 2 is not multiplying with that. 2 4th root of x squared plus 1, and this is to the third power. I thought I turned these things off. Let me turn them off. Okay, so I just say to turn that off. Now if 2 is multiplying with that, can you see the 2 is gonna go here on the top? And when the 2 goes on top, it's gonna cancel out with these 2. So this 2 and this 2 will cancel. And then what I'm gonna be left with is x over, right, this properly, x is over the 4th root of okay, sorry about that. So this is actually, let me zoom in further so that I can have a little bit more space to write my 4 here, and then say x squared plus 1 raised to the third power. And this happens now to be your derivative. This here is your f prime. Let me write this in red so that you can see that, or even blue. So this here happens to be the derivative, and this is how you solve it. So if there's anybody else who has any type of questions that they want me to solve, you can just comment down below. If you have any past papers that you want me to do, comment down below. Any types of questions, any past papers, you know, just say whatever you need me to solve, because this question I also got it from somebody else. So yeah, I'm gonna have a different playlist where I have the type of questions that people are asking or people are struggling with, and we'll address them so that we can help you guys with the exams. But other than that, I hope this video was helpful to somebody out there. I hope somebody got value out of it. That is the goal. And thanks for watching. I'll see you in the next one.